Math 3, Unit 9, Section 1. So today we're talking about volumes of solid figures, and we're going to get into, if you notice on the second page, truncated figures. Yes. What happens is they're basically, you're cutting off part of the figure, and you're figuring out what is left, okay? And we're going to get through that. But to start, we are just going to review how to find the volume of these figures. So, just as I said in 9.0, when you're taking the volume of a figure, you need to look and decide what kind of figure is this. Okay, and this is a triangle. So, my base area will be the area of a triangle, the triangle of this figure, and then we multiply by the remaining dimension, which we call the height. Okay? If you're looking at the triangle, we can see that this line right here, they're telling us that is 5. This right here is 4. But when you're finding the area of a triangle, what are we multiplying? Base times height divided by 2. Okay? So I need to figure out what this base is. How can I do that? Good. A squared plus B squared equals C squared. Okay? I have my C. Okay? So A squared plus 4 squared equals 5 squared. You could label this as an X, you could label it as a B, whatever you want, okay? So I have A squared plus 16 equals 25. We subtract 16. And I have A squared equals 9. And in order to find A, we take the square root, and A does equal 3. So, we want, in order to find our volume, it is our base area, I'm going to write that just as big B, times H. My base area, what will I multiply?
4 times 3 times 5.
Good. 4 times 3 divided by 2 is my base area times the height of this figure, which is going to be what?
6.
Very good. Okay. So I'm going to reduce this way. 2 goes into 4 2 times. I have 2 times 3, which is 6. And then 6 times 6 is 36. Very good. 36 feet cubed. All volume is in feet cubed, and that's because we're multiplying here. 3 feet times 4 feet times 6 feet divided by 2. Okay, any questions there on A? Okay, moving on to B. What would be this shape?
A trapezoid.
Very good. So we are going to find the area of the trapezoid and then multiply it by the height of the figure. Okay? So the trapezoid here, how do we find the area of a trapezoid?
Base 1 plus base 2 divided by 2 times the height.
Very good. So here is my base 1. What is my base 2? Do you guys see that value anywhere on the figure?
8.1.
Very good. So 8.1 plus 2.8 divided by 2, because we're taking the average of that. And then we're multiplying it by the height of the trapezoid here in order to get the trapezoid area. Do you see that value anywhere within this figure?
3.
Good. Do you see that there, how it's saying 3? The height there of the trapezoid, so this is 3. So that's multiplied by 3. So this right here is my base area. And then the height, the last thing I'm going to multiply by is what?
12.
12. Very good. So I would take my calculator out for this because we actually have to add this and divide by 2. And so we have 8.1 plus 2.8 equals 10.9, and then I'm going to divide that by 2, which is 5.45. Now, I like to leave the values in my calculator and just continue figuring out the problem. So I take that and then multiply that value. I just put times 3, and then I put times 12. And you could put times 3 times 12. But I end up with 196.2. Now, did you see any units on this figure? No. So then we just say units cubed if we don't know what it is. Are there questions on part B? Okay, C. What is our shape here? A cylinder, or specifically if we're looking at it in two-dimension space, it's what? A circle. Okay, so again, our volume will be our big base, our base area, big B, base area times our height. So how do I find the area of a circle?
Pi r squared.
Good, so pi, what would be my r though in this figure?
7.5.
Very good. 7.5 is my radius. So I'm going to have 7.5 squared. So that's the area of the base times my height, which is going to be 32. So again, in my calculator, I'm going to put 7.5 squared. Very good. We have 56.25 times 32, which makes 1,800. And don't forget that this has a pi in it. You don't have to multiply pi out. If you want to, you can. It's up to you. I'm going to leave it like pi, with pi though. And then this is still going to be centimeters what? Cubed. Do we have any questions on that one? We're all okay with finding the volume? Okay. So now this is building into more of what we're doing for Math 3. Okay, so pyramids and cones. First of all, when we're finding the volume of this pyramid, we know, or cone, anything that goes into a point is what when you're multiplying? 1/3. Okay, so again, this volume is going to be 1/3 times the base area times the height. So volume of pretty much every figure is your base area times the height, but if something goes into a point, you also need a 1/3, okay, because it's actually 1/3. This, if you were to put it all together, would actually be a cylinder, okay? So a cone is actually 3 cylinders. Okay, so what is this base area? How will I find this base area? Okay, what is my R?
6.5.
Very good. So R here is equal to 6.5. So if we're finding our volume, we're going to have 1/3. My base area is pi and then 6.5 squared. And then my height is going to be 10. Is everybody good with that? Okay. So in your calculator, what should I do first? What should I multiply first on this one?
Exponent.
You want to do exponents. Follow order of operations. So I'm going to go 6.5 squared.
42.25.
Good. And then we're going to multiply that by 10. And then I'm going to divide by 3. And we're going to round that to the nearest hundredth. Okay? So my answer is 140.83 pi centimeters cubed. That is my volume. Do you have any questions for me there?
Yeah. How many? Do you have to write out like the 2 numbers after all the time?
I think we should stick to that.
What if I wrote 140.8? Would I figure it right?
Okay. Moving on. Are we ready? Okay. Oh. Now, when you turn to the next page, when you read it, it says find the volume of the truncated cone, which was created by the right circular cone in part D. So these should have been on the same page. I'm sorry for making it go to the next page. But they're basically saying that this is the whole figure and we're taking a piece of it. Okay? So when we go to this next figure, we're going to transfer some information based on what we know here. Okay? So, looking at this figure, we know this radius right here is how much? What was the radius on the previous figure?
6.5.
Okay, good. 6.5. We also know, if you look at this problem here, they're telling us this height right here is what? 5. Now, I like to redraw my big figure, so I'm going to try to draw this. I know I'm not the best. Thank you, Cathal. Okay, so on the previous figure, what was the entire height? What was, of the actual cone, what was the height?
10.
Okay, that height was 10. And then they're telling us that this piece right here, that is 5. Okay, so we know the volume of the whole figure.
I don't know how to draw.
It's okay, you know, just do your best. What was the volume of the whole figure from the previous page?
140.83.
Please stop.
Pi.
Okay. Now, no, you can't do that with volume. Okay, but, so a couple things. I want to find the volume of the cone that was cut off. Okay, because if I find this volume right here of this cone that was taken off, I can just subtract and get the truncated part. Okay, so volume of this cone, we know that volume of a cone is 1/3 base area times the height. Now, if I know that this height right here is 5, and I know the whole height was 10, how much is that missing piece?
7.89.
10 minus 5 is 5. So this part plus this part needs to equal 10. It happened to be half. It won't always be half, but this height right here is 5. Okay, so that means I know this h right here is 5. Okay, now the issue I have is that this, I don't know what this radius is. Now,
It's half of the regular rate.
you are right that it's half, but let's pretend that it wasn't an exact half. Okay, like what if this had been 4 and this was 6 and it's not exact? In order to find that value, you want to set up a proportion or a ratio. So, what I mean by that is that the whole figure, we know the height was 10 over, over my radius, which is 6.5. And then we know it's proportional to the smaller cone. So on the smaller cone, I'm going to put the height, which is 5 on the top, but I don't know my radius, right? And so we're going to put an X. Notice that you always want to match them up. And I could have written this ratio differently. Like we could have gone 10 over 5 is 6.5 over X. There's a few ways of writing it. How do I solve, though, for something like this? Good. So we have 10x, because we're cross-multiplying 10 times x, and 5 times 6.5 is?
32.5.
Very good. And then we divide by 10 to both sides, and we get x equals 3.25. So that radius is 3.25. So now we can find the volume of that cone. Okay? So, in order to find the volume of that smaller cone, 1/3, my base area is going to be what?
3.25 pi 3.25 squared.
Very good. Pi times 3.25 squared, and then times that height, which is 5. So again, in my calculator, I am going to do what first?
3.25 squared.
Oops. 3.25 squared. And then I'm going to multiply that by 5. And then we're going to divide by 3. And what will I get if I round that to the nearest hundred?
17.6.
Yeah, 17.60, or you could write that as 17.6. So I have 17.60 pi centimeters cubed. So I know that the volume for this figure is that value. So how do I figure out the volume for this? What do I do?
So you subtract it.
You just subtract it. Very good. So 140.83 pi centimeters cubed minus 17.60 pi centimeters cubed. And I'm writing all this out so that if I look back at my notes, I know exactly where I came up with these numbers. and you end up with 123.23 pi centimeters cubed. If they didn't both have pi, I couldn't subtract them. I'd have to multiply out what pi is and then subtract them. But since they both have pi, we can leave our answer in terms of pi. Okay, do we have any questions there? Okay, so we're going to practice this again. Okay, are we ready?
Yep.
So, now we have a pyramid. Pyramid is the same as a cone. We know that anything that goes into a point when we're finding the volume, it's still our base area times the height, but we also multiply by 1/3. Okay, so also notice here they're saying it's a square base. So on a square base, if this is 6 meters, then what is this right here?
6 meters.
Very good. So my base area, so volume equals 1/3 base area times the height. So we have 1/3. My base, what am I going to multiply? 6 times 6. And then, do I know what my height is?
No.
No. We need to know the height down here. So, do I know what this length is right here?
Yes.
What is it?
3.
3. So if we're using the Pythagorean Theorem, we can even say that we don't know h. How will I write out this equation?
A squared plus B squared equals D squared.
Good. So I'm going to write that as h squared plus 3 squared equals 10 squared. H squared plus 9 equals 100. We subtract 9 to both sides. H squared equals 91. And I would put this into a calculator and take the square root, and we get h equals
9.54.
very good, 9.54. Is everybody good with that? Okay. So if we go back to finding the volume of this pyramid, I'm just going to multiply the height as what? 9.54. Yes.
We have to add all the units on the end of all of these too.
Just at the very end. Yeah, so once we're done, then we'll put our units in. So what will I do first on my calculator?
1/3 of 6 times 6.
Yeah, I'm going to go 6 times 6. You could also reduce the 3 if you want to, but we have 6 times 6. And then I'm going to multiply that by
1/3.
9.54. And then I'm going to divide by 3. You could really do it in any order. It doesn't matter. But I end up with 114.48. Now, do you see any circles in this figure? No.
Yeah.
So there's no pi. Okay? Pay attention to that. There's people that made mistakes on that last year. So if you don't see a circle, then there isn't any pi. Okay? 114.48 what?
Meters cubed.
Meters cubed. Okay. So there's my volume of this pyramid. Now we go here, and it says find the volume of the truncated pyramid, which was created by the pyramid in part F, which is right here, okay, where h is 4. So they're telling us this height right here is 4. Do we know what these sides are down here?
Yeah.
What are they?
6.
Very good. So I'm just going to cross out these, and I'm going to put 6. Okay, now based on what we did on the previous example, it's always a kind of good idea to redraw the figure with the whole figure there. And we want to figure out what is the volume of the pyramid that was cut off. Okay, so if I know the whole height here was what?
9.54.
Very good. 9.54. Can we figure out what this height here is?
Yeah.
What is it? How did he find that?
I subtracted.
Subtraction. Crazy.
I know.
5.54 is correct. Now, do we know what that base is? No. So what should we do?
Get that base.
Make a ratio. Make a proportion. Okay, I'm going to give you about 20 seconds here. With your partner, try to set up a ratio that we could do in order to find what that base is up here. Okay?
We have a partner.
Yeah, whoever you're sitting next to, talk to them, see if you guys agree.
I'm not sitting next to you.
Okay, anybody want to share how they set it up? Okay, Kyle, tell me.
I put 9.54 over 3 equals 4 over x.
Okay, 9.54 over 3. Now, here's the thing. We really don't want half. We want the whole thing. Now, you set it up this way, which will totally work, but I'm going to change it to 6. But you could have done it by 3 and then you multiply it by 2. Okay, so it's the whole length divided by, or the whole height was 9.54 divided by the whole base, which is 6. So based on me doing that, what would I put on top over here? 5.54 over x. Does anybody have questions about what I've done? Does this make sense? So notice we have the big height over the big base, and then this is the smaller height over the smaller base. So we will cross multiply here. So we have 6 times 5.54. Very good. So that means I'm just going to write this out. 9.54x equals 33.24. And then we would divide by 9.54 to both sides. And we get x equals
3.48427673.
Okay, but we're going to round that to the nearest hundredth, so what are we going to call it? 3.48. So up here, this is 3.48. So, can I now find the volume of the small pyramid? If you round it to the nearest tenth, then yes, but we're going to leave, I'm going to leave it like this. In your homework, if you want to go to the nearest tenth, that's fine, okay? So, volume of the pyramid on top is going to be 1/3 times my base area, which is going to be what? 3.48 times 3.48, because it's still square. It's still square, right? So it's base times height, or base times base, and then the height of that figure is
9.5.
nope, 5.54. And you can't see what I'm writing. Here we go. So, in my calculator, 3.48 times 3.48 equals that value. I'm going to go ahead and multiply that by 5.54, and then I'm going to divide by 3, and you get meters cubed. Now, is that my final answer?
No.
What do I do? Good. 114.48 minus 22.36 will give me the volume of that truncated pyramid. So
92.12.
very good. 92.12 meters cubed. Okay, do we have questions there? Yes. Yes. Okay, is there any confusion, anything I need to clarify? You don't understand where a number came from? What? In a minute. Okay. Are you ready? Can I move it?
Yeah.
Okay. So now, sometimes they will give us information and want us to find something different. Okay? Here is a square pyramid. They are telling us the height of the square pyramid is 24. And they told us the total volume is this. Now, let's write out our equation for the volume of a pyramid. What is that equation?
24 squared.
No, we're just going to write the actual equation. Volume equals 1/3 base area. Very good. Now, one thing about a square is that we know that the base, both of the dimensions are the same. So we can label them. How do we want to label them? We can label them with any variable. So we could do x, we could do a. Okay, x. So this is x by x. Okay? So if we're plugging in the information we know, do I know what the volume is? Okay, the volume is 1568. equals 1/3
X squared.
times x squared. That's the same as x times x, right? Because that's the base is going to be x times x. And then the height is what?
24.
And now we just have to solve for x. Okay? What would you do first to simplify?
Divide by 24.
Very good. And that makes 8. So I have 1568 equals 8x squared. What is the next thing I do? Okay, right here, 24 and 3, I just reduced those. Okay? So 24 divided by 3 is 8.
Then you divide by 8 to the other side.
Okay, good. So I'm going to divide by 8 to both sides. And so in my calculator, I have 1568 divided by 8, which equals 196. 196 equals x squared. How do I find what just x equals?
Square root of
X equals
You know your
14.
squares.
So the square root of 196 is 14. X equals 14. The question, though, says what is the slant height?
So now you plug in 14 for X, and then we do A squared plus B squared.
Very good. Okay, so if you're doing this, though, this whole thing is
14.
14.
We only need 7.
Very good. So if I were to draw this, right, that's 24. This piece would be 7, and then we're trying to find that slant height. So we'll call that C.
Yeah.
You can call it whatever you want. I'm going to call it C. So that means I have
7 squared.
7 squared plus 24 squared equals C squared. 7 squared is? 24 squared is? Equals C squared. When you add those together, you get
625.
equals C squared. We take the square root, and what does C equal?
25.
Very good.
Centimeters.
So, yes, 25 centimeters is
The slant, I shouldn't have said it.
the slant height.
One more centimeter. Is that what it always is? Is it
No, it's not always one more.
Bet.
Okay, any questions there? Okay, next problem. Okay, using the given information to find the missing dimensions. Shh. Okay, the volume of this cone right here is 1,680 pi centimeters cubed. You don't have to write centimeters cubed if you don't want to. This says radius of the lower base is 12 centimeters, which means this one is also 12 centimeters. Please stop talking. Height of the original cone, I do not know. Height of the truncated cone, we know is 15. Radius of the upper base of the truncated cone, I do not know there. Okay. So, do you see how we're just missing a height here? And I have all the other information?
Yeah, for the other radius.
Right, but let's start with finding this height. Okay? I can do that with my volume formula. Volume equals 1/3 base area times height. What does the volume equal? 1680 pi equals 1/3. My base area is going to be what? Pi times 12 squared. You can write it the other way though. And then times our height, which we don't know, so I'm going to put that as h. Okay. So to start with our calculator if you want to, 12 squared we know is,
144.
and we're going to take 144 and divide that by 3, which makes 48. So I have 1680 pi equals 48 pi times h. And that's a 1680, sorry. And so what would I do to get h?
Divide by 48. Pi.
Divide by 48 pi. So right there, do you notice how the pi's cancel?
Wow.
Okay? And then we will take 1680 divided by 48, and that equals 35. So my height is 35. So height of original cone is 35 what? Centimeters. Okay, so now we need to find the radius over here. How will I set that up? I need to use a proportion or a ratio. Okay, try to set it up here for me. Also, you might want to think about how you would draw this. What is this missing height right here? 20. Okay, so when you're making your ratio, you're going to use that 20. Can somebody tell me the proportion they set up? 35 over 12 equals, no, not 15. You're going to have to use the cone. 20 over R or X, whatever you want to do. So 20 times 12 is 240 equals 35R. Divide by 35. And so 240 divided by 35. 6.86 what? Centimeters. So we have 6.86 centimeters. And we found all the missing information there. Last one, we have a sphere. Yeah, sorry. Okay, sphere has a different formula. What's the volume of a sphere? What's that formula? It's, 4/3 pi r cubed. Okay, so 4/3 pi, and this would be 5 cubed. Okay, in your calculator, you want to do 5 cubed first. And then I'm going to multiply that by 4, and then we can go ahead and divide that by 3, and we will call that 166.67 pi yards cubed. Okay, if you notice over here, it's half of a sphere. And so volume, again, is 4/3 pi 9 cubed, because that radius is 9, and once you get that answer, you would divide it by 2. So, in your calculator, I would start with 9 cubed. Where am I at? 9 cubed times 4 divided by 3 divided by 2. And so you end up with 486 pi, and then it's going to be units cubed. What? Any questions?